13.
Action. What meetings you have then?
What?
Did you have a meeting?
Yeah, the class officer.
Oh, that's not much to do.
Okay.
Okay.
Hopefully, good enough.
We good enough? You can't have extra votes. Can't have extra votes. All right, let me give you, to help you out here. If you need it, most of you, a lot of you are doing good. Here's one way you can think about this. Is like for the mixtures, like with the alcohol and with the orange juice, we said like the amount of pure orange juice that you had. This one's going to come down to how much it's worth. Okay, how much it's worth each piece or each part. So in the end, if you got 20 pounds worth $2 a pound, it's going to be worth $40. So these two have to add up to $40 in some way. One might be 10 and one might be 30, one might be 15 and 25, but they have to add up to 40. So how many pounds of M&Ms were $2.50 a pound and raisins worth $1 a pound must be mixed together to produce 20 pounds of a mixture worth $2 a pound. The final mixture is 20 pounds. So that means you got to let one of them be X, the other one be 20 minus X. You got to watch it. You always got to think, can I let both of them be X? Then you're saying they both have the same amount. And is that guaranteed? Okay, it's not guaranteed. We don't have any indication that they both are, 10 pounds each. All right. Now this one works out to be a fraction of an answer. Okay, it doesn't work out to be a whole number. So what do we end up with? Marissa, what'd you end up with?
13 1/3 pounds for M&Ms and 6 2/3 for raisins.
Yep, and it ends up being 13 1/3, 6 2/3. Because when you solve here, I get 2.5x plus 20 minus x equals 40. Let's see, 2.5 minus x is 1.5x. If I subtract 20, I get 20. And that's where I get I think this one's the 13 1/3, if I remember right. Okay, for that one. Okay. All right, now homework. You got an answer key there, Matthew, for your homework? So if you want to look it over, let me just see it real quick. Make sure you did it. Yeah. Okay. All right, now homework-wise, and I gave you the answer. That doesn't mean it answers all your questions. Hopefully it'll answer the majority of them, but it may not answer all of them. The only thing I'll talk about 58, and then we'll see if there's anything else. Now 58, as an example in class, or in the book that it told you to look at, kind of give you an idea. Now, I think it's butter fat, is that what they're talking about? Yeah. All right, 2 gallons or 8 quarts, you got it at 2%. 2% of 8 quarts, and then we want to end up with 5%, but we still want 8 quarts. So we take some out and put more in. We don't just add 2 things together and get more than 8 quarts. So we got to take some out. So if you looked at the book, if you looked at what I have on the answer key, you're starting out with 2% of 8 quarts. We are going to subtract an unknown amount, which we'll call X, but that amount is at 2%. So we're going to take that out, but we have to add in the same amount. So this is where that X will stay. What's the percent of the amount we're adding in? It's pure, right? So it's 100%. So we're adding in 1x. So you got to think of that as 100%. This is 2%. Don't forget to make it 0.02. And that equals, we want it to end up equaling 5% total. So we got to take that amount out. We got to add that amount in. And then we're going to end up, now it ends up being like 0.24 or 0.24 divided by
0.98.
98. Or, yeah, 0.48 divided by 0.98? Or is it 0.24? Okay, 0.24 divided by 0.98, which reduces to 12 over 49 if you keep it exact. But if it's a decimal, it's like 0.24 and some change for that. But that's how you set that one up. Okay. Other questions? on any of those other ones that maybe just need a little bit more explanation? All right, good deal. I'll come by and collect those sheets here in a minute. We're going to have a chapter 1 test next Thursday. Okay, September 9th. So we got a few more things to finish up. You know, a couple people in the last class wanted just an all word problem test, but I told them I wouldn't do that. Okay, so maybe next time. So I will put some just regular problems on there, maybe a couple. All right. So we good here? All right, let's go into section. Whoops. And here's all those answers, which you should already have. Section 1.3, solving some quadratics. No guided notes, you're on your own there. All right, this is definitely, you've been exposed to this before, you've done it before, but we want to make sure we hit it. We become a little bit better at it, and so we want to go over some things from section 1.3 today. We're going to talk about factoring. Square root method, we're going to mention that. We're not going to go over that formally. And then completing a square. Those are the two main things we want to look at today. You solved linear equations in section 1 and section 2. That's just a single x. Now we're going to throw in x squared. So first thing we got to talk about is the zero product property. For any real numbers a and b, if a times b equals 0, then a equals 0 or b equals 0. All right, I'm just going to throw a couple quick cases up there. I don't even think you need to write them down. We'll do the ones you need to write down here in a second. But all this means is, like, and you know this, when you see something like 7x equals 0, well, you're like, yeah, x equals 0. If I put something like a times m equals 0, well, all that means is a equals 0 or m equals 0. That doesn't play a whole lot into what we need. That's not the hard part. Where it comes into play is when we have something like x minus 4 times x plus 3 equals 0. Now I got two expressions. It doesn't matter that I got expressions. Are they being multiplied? Yeah, as long as one of them equals 0, the whole thing equals 0. And so for the first one, x equals 4 will make it 0, and the second one, x equals negative 3. Now, it's also not limited to 2 things being multiplied. If you got 3 things being multiplied, a times b times c, then any one of them could be 0. All right, so it doesn't matter how many things are going to be multiplied. If it equals 0, if one of them is 0, the whole thing is. All right, so here's how we use it. Solve. W squared minus w minus 6 equals 0. Is that written as a product? No. It is a sum of 3 terms, or sum just because addition or subtraction, I can refer to those. What do I got to do? Factor it. Factor. So just go how we've always factored. What's w squared minus w minus 6 factor into? There's no constant in front of here. What multiplies the negative 6 adds the negative 1? It's going to be w minus 3 times w plus 2 equals 0. It is now a product. It is 2 things being multiplied. You could think of the first expression being your A, the second expression being your B. They multiply to 0. We got to find out what makes A 0. Well, just set w minus 3 equals 0. Set w plus 2 equals 0. Now I know a lot of you are just going to drop down and just say w equals 3 and w equals negative 2. That's absolutely fine. And so now when you have two answers, we use braces. Don't use parentheses because then it looks like an ordered pair, and it's not an ordered pair. And you're saying one answer is -2. You're saying the other answer is 3. Right. Now remember, if you're checking this, W equals 2, you're plugging that into for both W's. -2. So that's -2 squared minus -2 minus 6 equals 0. And just do a real quick check. -2 squared is 4. Minus a negative becomes a plus. I get 4 plus 2 is 6. 6 minus 6 is 0. So I know it works. And now W equals 3. And that gives me 3 squared minus 3 minus 6 equals 0. 9 minus 3. And then I get 6 minus 6. And then I get 0 equals 0. So both of them work. Nothing else will work. So those both work. So we got to factor it, solve that. Okay, second one here. Solve 2m squared equals 5m. Doesn't look exactly the same as the last one. Key thing here, though, is according to the zero product property, your equation has to equal what? Got to equal 0. Got to. It doesn't work otherwise. Subtract 5m. 2m squared minus 5m equals 0. Now, a lot of times people freeze on this. They see this because it's not the same as the last one. It still factors, though. It's missing the constant term. It factors because it has a GCF. What's the GCF? Factor that out. That's fine. If that's all that factors out, that's a start. But in this case, that's the only thing that'll factor. So you get 2m minus 5 equals 0. As long as you got a product and it equals 0, you can solve it. So now m equals 0 and 2m minus 5 equals 0. And so m equals 0, nothing else you can do with it. Add 5, divide by 2, m equals 5 halves. So I get my two answers, 0 and 5 halves. So each one will be slightly different, but we're still using the same concept. Okay, set this one equals 0, factor, see what you get. No, so this is a triangle, so you got either do grouping or you 4 times -3, -12, or you break up into 2 binomials. There you go. All right, if you're doing it by guess and check, it's not 2y and 2y, so I'll at least give you that. So you got to subtract 3, 4y squared minus 11y minus 3 equals 0 on here. Now when you're factoring, 4y and y, it's got to be -3. I believe That's a -3, and I believe that's a +1. Okay, so just double check by kind of foiling it. Now, 4y plus 1 equals 0. Y minus 3 equals 0. That gives me subtract 1, divide by 4, -1/4. Y equals 3. So -1/4, +3. So for that, so set it equal to 0. Got to do that first. No GCF. You're going to factor it like we do with all other trinomials. All right, let's take a look at one more factoring. Easy there. Okay. 18r cubed plus 16r equals 34r squared. I would always have my biggest exponent positive because theoretically you can move those two to the right, or you can move the one on the right to the left, but I would move the one on the right to the left. Subtract 34r squared. Now make sure you put it in descending order. 18r cubed minus 34r squared plus 16r equals 0. This one does have GCF. What's going to factor out of that whole thing? Justin Stevens, what do you think? 2r. Okay, put the r with it as well. So 2r. I'm going to take out a 2r. And then I get 9r squared minus 17r plus 8 equals 0. Now this is 2r. What's this going to factor into? And I'm going to tell you is 9r and r. You finish it from there. See if you can do it, guess and check. Only two things multiply to 8. 2 and 4 or 1 and 8. This has got to be those. Hayden, you got it figured out yet? I'll give you more time. Nice like that. Hayden, both sides have to be what?
Negative.
Good. Both sides have to be minuses. Got it?
9r minus 8, and then r minus 1.
Good. 9r minus 8, r minus 1. Okay, on that one. So you just got to have 9r times -1 is -9, and then -8 times r is -8, gives you -17. All right, how many answers am I going to have? There are 3 of them. You have to include this 2r right here. So I got 1, 2, 3 things being multiplied. So 2r equals 0. 9r minus 8 equals 0. And r minus 1 equals 0. And so that gives me r equals 0. This will be 8/9, and this will be 1. All right, one thing you got to watch. If when you're factoring, your GCF doesn't have a variable. Let's say you pull out, you got 3 times x plus 4 times x minus 2 equals 0. All right, so if you got that, does that 3 give us an extra answer? No, it has to have a variable with it. Okay, that's just, I mean, if you can set it equal to 0, but you don't have a variable. This would just be -4 and +2. So just be careful with that. All right, we're going to go into the next thing with completing the square. Just pay attention to this. If you have something like x squared equals 16. I think you know, I'm just going to take the square root of both sides. X equals plus or minus 4. All right, which is fine. If I have a quantity squared, we can do the same thing. I can take the square root of both sides. Because the square root of x minus 5 squared will give me x minus 5, and then I get plus or minus 18, square root of 18, and then I can solve for x. We usually don't see things written that way. But what's the problem with factoring? Does factoring work for every quadratic? No, not every quadratic factor. Completing a square will work for every quadratic. Okay. It can be a little bit messy at times, but it comes up in other areas, so it's something that we need to know. All right, let's go through how to do this. And I'm going to give you kind of some step-by-step instructions to help you out, to help you remember. All right, we're going to do, on the left is the problem. I'm going to do right below here on the right are kind of the steps. Now, steps 1 and 2 are interchangeable, as it says. It doesn't really matter if you do step 1 first or step 2. But you're going to, this is the one case, because I kind of preach, set it equal to 0, set it equal to 0. That's for factoring, and that's what you have to do. But for completing the square, we're not going to set it equal to 0. You want to isolate the constant term on one side of the equation, which means I'm going to take the 4 and move it over to the other side, which means I'm going to subtract it on both sides. So it's going to give me x squared minus 6x. I'm going to leave a little space here, equals negative 4. Now, step 2 doesn't come into play for this problem. It says make the coefficient of x squared equal to 1. It already is a 1 by dividing both sides by the original coefficient. If it was a 2 or a 3 or a 4, we'd have to get rid of that. But since it is a 1, we're good. All right, I'm going to try. I want to make sure you stay caught up. Now, what we're going to do is we're going to have to make it look like this. We're going to add a number in on this side so that this will factor into something squared. Okay? Does anybody know what that number is just looking at it? Okay, what number can I put in here to make both sides factor? Or not both sides, just the left side into something squared. Okay. The number's going to be a 9. I'll show you how to get it in a second. So when we do this, we're going to put in x squared minus 6x plus 9 equals negative 4 plus 9. So we got to go back to our old rules. If I put something on one side, I got to put it on the other. What's x squared minus 6x plus 9? What's that factor into? Make sure x minus 3 times x minus 3. So it's going to be x minus 3 squared equals positive 5. All right, there's a procedure to get that 9. Does anybody remember it? Okay. I don't love how they word this, but it does work. So here's what you're going to do. This is the completing the square part. Take half of this coefficient and square it. That always works. So you're going to add the square of 1/2 the coefficient of x to both sides. So by this, you're going to take negative 6. You're going to divide it in 2. Let me do something here. Let me give myself a little more room. You take negative 6. You cut it in half. It's negative 3. And then you take that and you square it and you get positive 9. Okay. That number is what's going to go into both of those slots. Okay, that's how you always take half of that coefficient squared. Because now we got a quantity squared equals a constant, and now we can take the square root of both sides. And then we make sure anytime you take the square root of the constant, you do plus or minus. Well, this is kind of the last step, is you factor and then we simplify. Simplifying is with the taking the square root and all that other stuff. So I get x minus 3 equals plus or minus square root of 5. Add 3 on both sides. You get 3 plus or minus square root of 5. Remember, that's two answers. 3 plus square root of 5 is one answer. 3 minus square root of 5 is the other answer. We want to keep it in the exact form unless we're told otherwise. All right, so there's your steps. Okay. Key one is typically, how do I get this number? All right, we need to take a look at one where there's a number in front of the x squared. Okay. One thing I'll tell you in this case, no decimals. Okay. You do not use any decimals within these problems. Keep everything in fraction form. So 2m squared minus 5m plus 8 equals 0. All right. Follow our rules. We're going to have to do step 1 and step 2. So step 1, I'm going to move the 8 over to the other side. 2m squared minus 5m. And we'll leave a space equals a negative 8. And we're going to have to figure out what goes into this space. And it doesn't matter about any of your other signs. This is always going to be a plus. Always going to be a plus. Now, before I do that, I got to do something else. Actually, I probably should have waited. I got to get rid of that 2. So to get rid of it, this has to be a 1. All right, so to get rid of this, you're going to divide everything. Since there's nothing there, I'm not going to worry about it, by 2. If something doesn't divide evenly, keep it a fraction. If it divides evenly, then make it a whole number. So it's going to become m squared minus 5 halves m plus, that's not affected, equals negative 4 plus, and then we're going to have a blank there. All right, this is not as easy to figure out what goes there. So you're going to have to need to know that procedure. Take half of the coefficient of m. Well, half of it is not a whole number. So it's probably easier to multiply it by a half. So take negative 5 halves times 1 half. That is negative 5 fourths. This number will come up later. We'll circle it for now. You're not done though. What do we still need to do that number? Square. Because here's what happens. Whenever you square a negative, it becomes a positive. That is why this is always going to be a plus. 25 over 16 will go in both of those blanks. So I got m squared minus 5 halves m plus 25 over 16 equals negative 4 plus 25 over 16. This will factor into something squared, and then we're going to have to do that and figure out what that is as a fraction. We'll do that in a second. Okay, now, let me just refer back to that last problem for a second. That last problem was x squared minus 6x plus 9. And that was going to be x minus 3 times x minus 3. And that's going to be x minus 3 squared. You've got to have the same two numbers that multiply to 9, add to negative 6. I need the same two numbers that multiply to 25 over 16 and add to negative 5 halves. All right. Do you know, Matthew, you know those numbers off the top of your head?
Yeah.
What are they?
Negative 5 over 4.
Negative 5 over 4 and negative 5 over 4. This number will always be that answer. Okay? That's why I circled that. 5 over 4 times 5 over 4 is 25 over 16, and it adds up to 5 halves. So this is going to be m minus 5/4, make sure your signs match up, squared. Now what's negative 4 plus 25 over 16? You can use your calculator, but you need to get good at adding and subtracting fractions anyway. It doesn't hurt. So negative 4 plus 25 over 16. I get a common denominator of 16, which means this becomes negative 64. And what's negative 64 plus 25? I believe it's negative 39 over 16, correct? All right. Some of these do not come out nice, like you don't get whole numbers. All right, Brandon, what do I gotta do now?
You gotta take the square root of both sides.
Good, take the square root of both sides. So you take the square root, m minus 5/4 quantity squared equals plus or minus square root of negative 39 over 16. Treat it as your square root of the top and the square root of the bottom. That's the easiest way to do it. And then we'll reduce when we need to. Well, what's the square root of 16? 4. Over here on the left-hand side, you're going to be left with m minus 5/4 equals plus or minus square root of negative 39 over 4. Now make sure you're clear that 4 is not underneath the radical. If you do this right, these will match up, those constants on the bottom. Okay, in like 99% of the time, there's like one case or one situation where it doesn't. All right, we're almost done. Move the 5/4 over. Plus or minus. All right, what happens when you got a square root of a negative number? What's that give us? Remember, gives us an I. Gives us an I. Now 39 does not simplify. So we're just going to move the I out in front. So it's going to be 5/4 plus or minus I square root of 39 over 4. And you can leave it like that. That would be fine. All right. Now, some people will do this. I mean, that's equal or equivalent, whatever. Okay, so we're fine. So they can get a little bit messy. No decimals when completing the square in your answer or your work. Okay, make sure you keep it like that. All right, so that's the first part of quadratics. Page 115. Now, I know I got them out of order because 41, 42, and 46 are all completing the square, and then those all factor in some form. Okay, so 1, 2, 3, 4, 5, 6, 7.